Hey there, in this example we are going to graph a cosecant that is transformed, and the first thing we're going to have to do is find the guide function. So the guide function is the reciprocal function. I am also going to reorder this. I prefer to have this vertical shift all the way on the right and not confusing the coefficient of the function. So the reciprocal function for cosecant is sine. So this will act as the guide function. And that is what I want it to look like. So now we are going to find the 5 characteristics for the guide. Reflection, yes, because there's a minus sign in front, there's a reflection. Amplitude. The guide function will have an amplitude of 2. It is the absolute value of the leading coefficient. The cosecant function has no amplitude. Amplitude is the maximum distance from the center line to the top or bottom of the graph. And since cosecant goes up and down forever, there is no amplitude. But the guide function does have an amplitude, the absolute value of the leading coefficient. So now we have, let's see, reflection amplitude period. So the period is going to be 2 pi divided by the leading coefficient of the angle. The leading coefficient of the angle is 1 right there. And since a sine function, a basic sine, has a period of 2 pi, we use that in the numerator. Phase shift. Phase shift is opposite of what we see inside. We see a negative pi, so that tells us the phase shift is positive pi. In other words, we are shifting to the right pi radians. And then our last characteristic is the vertical shift, which is on, I like to put it on the far right. Sometimes it's on the far left, but I find that strange. So I put it on the far right, and that's an upshift of 4 units. Okay, so the guide function is a sine function. We need to know what the shape looks like. The shape of our guide function, the shape of a sine, looks like that. And there are 5 key points. Those 5 key points fall on, well, 3 of them fall on the center line, and then there's a high point and a low point. So those are the key points that we will put into our graph. So let's get started. The vertical shift is 4, so we want to keep that in mind when we draw our coordinate system here. So I'm going to put the y there and the x here. And let's go ahead and start with the phase shift. We always start with the phase shift. That's going to be the left endpoint of the first period, or the principal cycle. So let's call that pi. And since the period is 2 pi, we are going to go to the right 2 pi in order to complete the first period, or the principal period, or the principal cycle, whatever you call it. So I'm counting 4 of these little squares as pi radians. So now I've got a period of 2 pi right here. And let's go ahead and draw our center line. So we're going to go up to 4. 1, 2, 3, 4. Actually, let me just put tick marks on there. That'll be a little bit easier to count to 4 right there. And then the center line is going to come right here. Okay, so now let's go ahead and toss in our key points. We have a left, center, and right key point right on the center line. And then the midpoint between these two, we go up. There's a reflection though, so we're actually going to go down. So normally we would go up, but because there is a reflection, we go down. The amplitude is 2, so we'll go 2 units this direction, and over here we'll go 2 units up. So now we can draw our guide function. That is our guide. Now, anywhere that the guide function crosses the center line, the reciprocal function is going to have an asymptote. So I will draw 3 asymptotes, one going through each of these center line crossing points. So those are the asymptotes. And now we fill in the blanks. So the reciprocal function will put a u above right here and a u upside down right there. That is a picture of the first period, or the principal cycle, of cosecant. And I think that's it. Yeah. All right. So let me know if you have any questions, and I hope that helps.